I guess I had not unmuted, so you didn't hear a word I said. I guess I hit the record and forgot to hit unmute. No, never mind.
Yeah, that happens. That happens.
Yesterday was one of those days with the computer. Every time I did something, my computer just went wonky, and I'd have to shut it down and restart. So today has at least been better on that sense, but my head's been hurting all day.
No, that's not good.
I think that's pretty much from the day I had yesterday with the computer. And let's see, we get down here yet. PBA Linux 01 that we're logging into. So I'm going to turn it off and turn it back on and see if that's my problem.
That's what I just did.
Now my virtual computer's doing what my real computer was doing yesterday. Kind of weird. Come on. Okay, I guess it just turned off. Now I can turn it back on. And I know there's a way to get out of that. I just can't remember how. I'm going to have to play with it and figure it back out, I guess. Okay, and it is already logged in as administrator. So that brings us down to test 2. And we'll go to applications, system tools, and settings. And then we're going to click on network down here towards the bottom. And then the little settings wheel next to the wired connection. Then IPv4, we want manual, and my addresses were already completed. So we click apply up here in the upper corner. That box closes, and then we want to close this inside box. In Linux, we can view, change, and verify network settings on the client host in a similar manner you can do in Windows. Linux enables you to manually and automatically configure network interfaces, routing tables, to include adding, starting, stopping, restarting, deleting, or reconfiguring network interfaces. In this task, you will view, change, and verify network configuration settings. So we'll open a terminal, get ready to tell it what we want it to do. First, we'll switch users to the root account. SU space dash. And if you have to ask what the password is by now, I would be surprised. I think we've only typed password 3,000 times in the last few weeks. All right, and then let's clear the screen. we'll use the IP space route. And it shows the list of the current routes. So there's a default route via 192.168.0.250 through ETH0, static metric 100. And you can see another route here and another route here. We can also use the route command /sbin /IP space route. And so you can see that's pretty much the same output. It's just a matter of where you're running the command from. And next we're going to add a route. So we'll clear an IP space route add 192.168.0.250 DEV ETH0 DEV space ETH0. I don't know why I get that backwards a lot of times. I guess it's because it's V4 there. Okay, so we just added a route to the routing table, and to verify the route, we type IP space route, and you can now see the route that we added into the routing table. And we can also delete the route, so I'll up arrow twice, and then come back and just change add to delete, and that way I make sure I get all the numbers the same. And IP, I use my up arrow again and come back to IP route, and you can see that the route that we added has been removed. Okay, here we're going to look at either adding a single host or a specific network to a route. -net specifies the network. ETH0 is the network interface. Okay, so to add the network, we'll type IP route add 192.168.0.0/24 DEV ETH0. Okay, we'll clear the screen and do an IP route again. And you can see where the new network was added to the routing table. Okay, up arrow twice, 3 times if you did the clear. Come back and change your add to delete or DEL. And then you can delete that network. IP route again, and you see that it's been taken out of the table. static routes are defined in a file named route dash and then the interface. In this case, it's route dash ETH0. The file is stored in the etc sysconfig network dash scripts directory. And we want to first look and see that the file and the directory exist, and they want to know, well, if they're doing the -L, we get our permissions as well. So /etc/sysconfig /network dash scripts CRIPTS /. So that's specifically checking for the directory. So it lists the directory and then all of the files in the directory. We are looking for route. And you'll notice that there is no route dash ETH0 file. So we're going to create the file and edit it. So clear your screen and then VI /etc /sysconfig /network dash scripts /route dash ETH0. Now we're in the file, we'll hit I and go into the insert mode. And now we're on step 15 and we type this into the file. Default space 192.168.0.250 space DEV space ETH0. Hit enter and come down to the next line, and we got 10.10.0.0/24 via. So this is a route 168.0.250 DEV. Oh, it's 250 space DEV space ETH0. And hit enter and come down to the next line, and we have one more 172.17.1.0/24 space via space and then the 192.168.0.250 DEV space ETH0. Okay, so our default gateway here is the 192.168.0.250, and these are the two networks, or the two static routes for the networks, 10.10.0.0 and 192 or 172.17.1.0. Right, now we'll hit escape and then :WQ to write and quit. Now that file is saved and we can edit it if we need to. And we're on to task 4, debugging and network configuration issues. We can have loss of connectivity, the network not available, or no response from the network. To resolve those issues, we use ping and trace the routes. Ping sends literally a tone down the line from one computer to the other to see if it's received, or a packet. Okay. And we can use either the name or the IP address. So in this case, we're going to ping 192.168.0.1. And Linux's ping pretty much goes on forever. Hit the Control C to break the cycle. And you can limit the number of pings that are issued by typing ping-C, the number of attempts, 5, space, and then the IP address, 192.168.0.1. Notice this time it will only ping 5 times, and then it breaks. Okay, clear the screen. Didn't work. Come on, clear. And now we're going to try to ping the server by its name, plabs. Now make sure this computer's on first, and this is going to fail anyway, but eventually we'll get it, plabs. And make sure you spell it A01. Okay, name or service not known. So we're going to have to add it to the host file. Clear the screen, and then vi/etc/host with an S. Then hit the letter I. Come down to the bottom, hit enter, and 192.168.0.1. We want to call that plabs A01. So we've now added it to the local host file. We'll hit escape to come out of the file, and :WQ to write and quit. Now you're back at the command prompt. And we're going to once again ping plabs A01. And if I spelled it right both times, now it'll start pinging. Okay. Control C to break the cycle. And if you know the IPv6 address of the system, you can use it to ping the system. Else, you can also use the system name to ping with the ping6 command. All right, so we're going to ping 6, the local host. Control C to break the cycle. You can see it's working. 0% packet loss there tells me it's working. Clear the screen. And now we're going to use trace route. It shows the number of hops that are taken to reach a specific destination or system, and it determines the path for packets that are being sent to the destination. All right, so we'll trace route to the IP address 192.168.0.250. Remember, that's our default gateway address. Okay, so there was one hop to the gateway. You can determine the path for a destination that is outside the network by typing traceroute 4222. It will get blocked because the firewall is blocking the packets and does not allow them to go outside the firewall. And then they suggest, oh, you can try this on your local computer. Similar to ping 6, traceroute 6 works with the IPv6 and performs the same task as traceroute command. So if you did that on your local computer, you'd have to disable your firewall or allow it to go through your firewall. So we'll do a trace route 6 to the local host. Oops, that goes together. Trace route, no space, 6, local host. And again, it shows it's one hop. And clear the screen. Trace path command is similar to the trace route command. However, trace route command requires root privileges. On the other hand, trace path does not require root privileges. Since we're logged in as root, we can do either. Trace path apparently can be used by a user. 192.168.0.250 again. That was our default gateway. And there it goes. One hop. And now we're done with lesson 2 for module 6. With the configuring the client's network, managing network interfaces, debugging network configuration issues.